Our next speaker is Darren Galpin. We'll just get up his, there you are. Yeah, so as Andy hinted, data is very important. We just had a talk on that. Automotive is very important. Our next speaker is a challenge paper. The challenges of developing silicon for automotive. Darren is formerly Director of Functional Safety and Verification at UniSemi Power. He previously worked at SiFive, Renesas, Infineon and STMicroelectronics, which is where we first met, and is the current IEEE Computer Society Treasurer and Secretary of the IEEE Functional Safety Standards Committee. And over to Dan.
Thanks, Mike. Okay, the challenge of developing silicon for automotive. So, the usual problem, Mike comes along.
Hold it closer to your mouth.
Right. So Mike comes along some months in advance and asks you to come up with 3 points to summarize your slide and then presents it to everyone. And you suddenly realize some months down the line, you've actually got to live up to the things you sent out, particularly when you wrote those points when you were having some problems and it was all driving you a bit. So the real problem, particularly if you're a small company and you're doing automotive design, is actually to work out what the size of the problem facing is before you actually start. Why is that? Because you've got standards. Okay. So we have ISO 26262 as a standard, but the problem is everyone interprets it slightly differently. And here are some examples that I've come across over the years. So if you're trying to work out what you want to do for verification, and you are looking around for what metrics do you need, if you go to part 6, which is for software, it defines structural coverage requirements. Whereas if you go to section 11 on the verification of digital components, does it? It simply doesn't, not at all. So the question is, do these apply to you when you're doing your verification or not? And it depends on whether you view RTL as a kind of software development or not. And different people will give you a different answer depending on what their viewpoint is. Another kind of difference which is fault injection, and I've had conversations where I've had both of these answers. I've spoken to EDA companies and they'll tell you it's mandatory. You have to do fault injection and we've got nice shiny tools to help you do it. I've also spoken to an ISO 26262 trainer who's then come along and said actually it's not mandatory at all. So what actually should I do here? What is enough? What is nice to have? Where is the independent guidance on what I should actually be doing? Still more reasons why there are conflicts of interests. Now, the assessor organizations will sell you templates for checklist analysis steps and many things to help you along these way. And they're actually very useful. I mean, I use some of them myself and they really help you get up to speed quite quickly. But the question is, should assessor organizations really be selling you things to help you get through their assessments? They're useful documents, they're just not independent. And if you're getting the documents and the assessment from the same organization, is that a single point of fail, which is what we're meant to be avoiding? And as an example of where this can lead, who remembers Arthur Anderson and Anderson Consulting from the financial world in the past? The risk with all of this is that you actually end up tailoring your flow and your results to what an assessor wants rather than what the standard requires. And it's unclear up front when you're starting for the first time what you actually have to plan for. And then assessments themselves. Not everyone actually gets externally assessed. Some of the bigger companies kind of are big enough to assess themselves and people are quite happy with that. And if that's the case, shouldn't actually be good enough for everyone. Particularly as if you're bringing in any IP from outside, you have to do an assessment anyway as part of the ISO 26262 flow, and you have to analyze it for usage within the context of your system. So does the IP you're bringing in really have to be assessed in quite the same way? And as a smaller player, basically you're doing the assessment anyway as a badge so that you can go up in front of whoever you're trying to sell to and say, yes, we've done it. Here's our stamp. Whether it means anything or not, that's another question. Lack of standardization. So we kind of touched on this. There's no standardized way of doing things and no agreement on what is needed at each step. You can go to different people, different flows, and get different answers. And there's no agreed standards for sharing the information you do have. If I want to sell my IP, give the information about it to someone, what form does that have to be in? I don't have ways for a lot of that in tending to write Word documents, might be Excel sheets, but there's no easy schema where someone can then simply import that information into their system and use it. Now there is IEEE P3332 attempting to address this with defining methodologies, databases, design languages needed to support common usage needs and the interoperability between different domains. And it's also looking at just automotive, but can I reuse that, say, defense, military, wherever I need to share this information? But the problem is it's not there now. I mean, it's just starting. They're aiming to publish something in 2026, which is great, but people will then need to take that and walk with it. But we kind of need things now. And actually, the act of trying to standardize things actually forces people to look at what we really do need and what really needs to be in there, and actually does help to concretize things. But also, there are plenty of other standards out there which you may need to think about. You've got the 21448 SOTIF, which is safety of the intended function, and also automotive cybersecurity. So how are they going to affect this? What other things do I need to bring in? And actually, if you look at connected vehicles and anything which affects semiconductors, there are over 230 standards out there. And there's no way you can actually comply to all of them and know what they all are. An example, with autonomous vehicles, are they actually robots? You know, if they're going around making their own decisions, you know, it's what robots do. So should those standards apply as well? So then we've got problems, recruitment. And I mean, we talked about AI earlier, and these images are developed by AI. And just look at how many small mistakes there are in the details when you're trying to use them. Yeah? But if everyone's doing things differently, try finding recruits to your organization. I mean, some companies split out safety architecture from safety management, others don't. So it also means if you're looking for a job, how do you know what you're going to fit? And it all takes time. And you can lose people when you didn't intend to. And we also need, when people are coming out of university, to be taught safe design from the start, so that when we're building designs, we're not trying to retrofit a lot of this safety stuff, bussing us in. They're already done from the start, so it becomes a lot less expensive. Design challenges. Okay, we all know about hardware safety mechanisms, but what do you pass to customers and what do you do yourself? And because hardware makes the customer's life easier, but it costs area and effort, particularly if you've got to replicate it across a chip, across a NOC or whatever. Software is much easier from an IP point of view because it makes the problem someone else's problem. But does that fit customer expectations? And are we loading customer routine so heavily that they can't reach the failure in time metrics? And what is the balance between the two? That's also going to be different if you're doing a system element out of context or not. And it's all largely guesswork at the moment based on what your expected customer set is. Design challenges. Different IP suppliers have different safety mechanisms, and they'll protect up to their boundaries, but then how do you protect across the boundary, particularly if you kind of got a bus going into a chip? You mean that may mean you need to open up the IP, creating a verification problem, even if you're allowed to open it up, and sometimes you're not. But even if you buy all of your IP from the same vendor, it doesn't guarantee the safety story is coherent. These larger suppliers are going through acquisition, and disparate parts of the companies don't always do the same thing. So how do you glue it together when they're all slightly and subtly different, and how to find this out earlier rather than later? Verification challenges. So ASIL levels require different diagnostic coverage, should that apply to structural. We all talked about functional coverage in the previous talks, but that's actually only mentioned once in ISO 26262 in part 11, and then only in terms of fault injection. So how much is actually good enough? And actually, if you look at ISO carefully, the 26262, it says the quality and completeness of a test bench is measured in terms of its capability to activate the circuit under test. It could be measured in terms of functional coverage, which is not really true. The quality and completeness is based on how much of the design you're checking. The functional coverage doesn't demonstrate that all of your test bench checks were exercised and you're not checking the whole time, then you actually hit the ISO metrics and So the ongoing challenge is standards really are a guide at the moment, but shouldn't be seen as the target in themselves. If you want a quality delivery, it goes beyond the current standard. And standards change. So currently there's a revision 3 of ISO 26262 starting up. Does that mean that once that is ratified, anything currently under development using the old one needs to rev up to the new one? Do you need to add things there? Depends on what your customers signed up for. And then when that's over, what other things have changed? And does it ever stop?
Okay, thank you, Darren. Thank you.